Welcome to Aeronet's visual simulation training program for the Airbus A320. The aircraft electrical system is comprised of AC and DC systems. The AC system is 3-phase 115 200 volts and the DC system is 28 volts. The aircraft AC electrical power sources are 2 engine-driven AC generators, 1 APU-driven AC generator, an emergency AC generator powered by the ram air turbine, and external power. If all other power sources are inoperative, a static inverter will convert battery DC power into AC power for limited use. The aircraft DC electrical power is supplied through 2 main transformer rectifiers, or TRs, which convert AC power to 28-volt DC power. The DC system has a backup essential transformer rectifier which will power the essential DC system from the emergency generator in the event of failure of the 3 main generators, or if TR1 and TR2 are faulty. As a backup, 2 batteries can power some of the DC circuits if all other power sources are inoperative. Each of the 2 engine-driven generators, or the APU generator, is capable of supplying the entire aircraft network. If all 3 main generators fail, the emergency generator can supply part of the AC and DC systems. When there is more than 1 power source available, the power source chosen to supply electrical power depends on its priority. When operating, the engine-driven generators have priority over the APU generator and over external power. External power has priority over the APU generator when the external power push-button switch is selected on. The emergency generator and batteries have the lowest priority. The electrical generators are automatically controlled and monitored by generator control units, or GCUs, and external power is controlled by a ground power control unit, or GPCU. The GCUs and GPCU determine which power source takes priority by controlling the generator line contactors. The electrical control panel is located on the overhead panel. The emergency electrical power panel is located on the left side of the overhead panel. The ECAM electrical page is automatically displayed in the event of an electrical fault, or can be displayed by pressing the electrical push-button switch on the ECAM control panel. The external power connector is located forward of the nose gear, with external power available and not in use lights located on the interphone panel. The various aircraft electrical components are protected by 2 main types of circuit breakers, or CBs. Green or monitored CBs will trigger the ECAM warning CB tripped if the CB is out for more than 1 minute. Black CBs are unmonitored. CBs with yellow rings are to be pulled for the flight on batteries only procedure, and the red CBs are for the wingtip brakes, which can only be reset by maintenance on the ground. The electrical system is normally powered by 2 engine-driven integrated drive generators, or IDGs. The generator is driven at a constant speed by the integrated drive to supply the electrical system with up to 90 kVA of power at 115 and 200 volts with a frequency of 400 Hz. The 115-volt supply is used to power normal electrical components, with 200 volts supplying higher load components, such as hydraulic pumps. The engine generators have priority over all other electrical sources and cannot be connected in parallel. A third generator driven directly by the APU without an integrated drive produces the same power as each engine-driven generator. The APU generator can replace either or both engine-driven generators at any time in flight or on the ground. The APU generator is normally used on the ground when ground power is not available and the engines are not running. Each generator has an associated generator control unit, or GCU. The function of the GCU is to control the generator voltage and frequency output, to control the generator priority, to protect the generator and the electrical network, and to supply indications and warnings. The GCU controls the connection of the generator to the electrical system by the generator line contactor, or GLC. Line contactors are used to connect and disconnect various power sources to the electrical system and are controlled by the GCUs. The ECAM electrical page displays the line contactors by green lines when they are closed. The green line is not displayed when it is open. The Generator 1 and Generator 2 push-button switches, located on the overhead electrical control panel, control the engine-driven generators, their respective generator control units, and generator line contactors. With the generator push-button switch in its normal on lights-out position, the generator will be energized, and if the generator electrical output is within limits, the generator line contactor will close. With the generator push-button switch selected to the off position, the generator field is de-energized and the generator line contactor opens. Anytime a generator push-button switch is selected off, the fault circuit is reset. Touch the Generator 1 push-button switch to turn it off. The Generator 1 or Generator 2 push-button switch will indicate fault if its associated generator control unit detects a fault within the generator, thus opening the generator line contactor, or if the generator line contactor opens when the generator push-button switch is in the on position. When the Generator 1 or Generator 2 push-button switch is on, the ECAM electrical page displays Gen 1 or Gen 2 in white, changing to amber if generator load, voltage, or frequency are outside set limits. The indication for load, voltage, and frequency are normally green when within limits, changing to amber if its limit is exceeded. When the generator push-button switch is selected off, the generator parameters are replaced with a white off and Gen is displayed in amber. The number 1 or 2 will be displayed in white if the engine is running and amber if shut down. When an IDG malfunctions, it can be disconnected from the engine through the use of its respective IDG push-button switch on the electrical panel. The guarded IDG1 and IDG2 push-button switches will indicate fault, and an ECAM warning is generated if the IDG outlet oil overheats or IDG oil pressure is low. The low oil pressure warning is inhibited when engine N2 is low to prevent nuisance warnings. Touch the IDG1 push-button switch to disconnect IDG1. The spring-loaded IDG push-button switch will disconnect the respective IDG from its drive shaft when pressed momentarily and should not be held longer than 3 seconds to prevent damage to the disconnect mechanism. Maintenance personnel only can reconnect the IDG. Caution: do not press the IDG push-button switch if the engine is not running or is windmilling, as the IDG will be damaged when the engine is started. The ECAM electrical page displays the label IDG normally in white, changing to amber if the IDG outlet oil temperature exceeds 185 degrees Celsius, the IDG is disconnected, or IDG oil pressure is low. The IDG oil temperature, normally green, will change to amber if the IDG outlet oil is above 185 degrees Celsius. Disc is displayed in amber if the IDG is disconnected, and low pressure is displayed in amber if IDG oil pressure is low. The 1 or 2 legend is white if the associated engine is running, and amber if it is not when the FADEC is powered. With the APU generator push-button switch in its normal on lights-out position, the generator is energized, and the generator line contactor will close if the generator parameters are normal and external power is not selected on. The APU will not supply an electrical system that is powered by the engine-driven generator, as they have priority over the APU generator. Selecting the APU generator push-button switch to off will de-energize the generator and open the generator line contactor. The fault circuit is reset anytime the push-button switch is selected off. Touch the APU generator push-button switch to turn it off. The APU generator push-button switch will indicate fault when the APU generator control unit detects a fault, or if the APU generator line contactor opens, except when the APU generator push-button switch is selected off. The APU fault light is inhibited whenever the APU speed is low, or if the APU generator line contactor opens when a power source with a higher priority is connected, such as external power or an engine-driven generator. The ECAM electrical page will display the label APU Gen in white when the APU master switch is off. With the APU master switch selected on and the APU generator push-button switch selected off, the label APU Gen will appear in amber and off will appear in white. When the APU is running normally and the APU generator push-button switch is on, the ECAM electrical page will display APU Gen in white, changing to amber if APU generator load, voltage, or frequency are outside set limits. The indications for load, voltage, and frequency are normally green when within limits, changing to amber if its limit is exceeded. The AC buses, AC Bus 1 and AC Bus 2, supply various components of the electrical system. Normally, Generator 1 supplies AC Bus 1 through its generator line contactor, which then supplies TR1 and the AC Essential Bus. Generator 2 supplies AC Bus 2 through its generator line contactor, which supplies TR2 and the AC Ground Flight Bus. The ECAM electrical page displays AC1 and AC2, normally in green, changing to amber when the corresponding bus is off. AC Bus 1 and 2 each have an associated bus tie contactor, which allows them to be powered by different power sources. The bus tie contactors are controlled by the bus tie push-button switch located on the electrical panel. The bus tie push-button switch is normally in its auto lights-out position. The bus tie contactors open or close automatically to maintain power supply to both AC Bus 1 and AC Bus 2. Both bus tie contactors will close to allow both AC buses to be powered when there is only one power source. such as when external power is supplying power. The APU generator is supplying power. One engine-driven generator is supplying power. Only one bus tie contactor will close when there are two power sources supplying power, as for an example, one engine generator and the APU generator. With the bus tie push-button switch selected off, both bus tie contactors open. Touch the bus tie push-button switch to select it off. With only external power, the APU or one engine powering the electrical system, both bus tie connectors will close, powering both AC Bus 1 and AC Bus 2. With one engine running and powering its associated AC bus and the APU generator available, only one bus tie connector will close to allow the APU to power the other AC bus.
The AC essential bus is normally powered by AC Bus 1. In the event of a failure of AC Bus 1, the AC Essential bus may be powered by AC Bus 2 through the AC Essential feed contactor. It is controlled by the AC Essential feed push-button switch located on the electrical panel. Touch the AC Essential feed push-button switch to supply the AC Essential bus from AC Bus 2.
With the AC Essential feed push-button switch in its normal lights-out position, the AC Essential bus will be supplied by AC Bus 1. By selecting the AC Essential feed push-button switch to alternate, the AC Essential bus will be supplied by AC Bus 2. Touch the AC Essential feed push-button switch to select alternate.
The AC Essential feed push-button switch will indicate fault in amber with an ECAM warning if the AC Essential bus does not have an electrical supply. If there is a total loss of the main generators, the AC Essential bus is automatically supplied by the emergency generator or by the static inverter if the emergency generator is not available.
When powered normally, the AC Essential bus indication will be displayed in green, changing to amber if the AC Essential bus is not powered or is malfunctioning. The AC Essential shed bus is powered by the AC Essential bus. In flight, the AC Essential shed bus will automatically shed if only battery power is available in order to reduce the load on the electrical system. The only ECAM indication for the AC Essential shed bus is an amber shed if the AC Essential shed bus has been automatically shed due to battery power only. When the galley push-button switch located on the electrical panel is in its normal auto lights-out position, the main and secondary electrical circuits of the galleys are supplied with electrical power. In flight and on the ground, with only one engine generator operating, the main galley circuit will be shed to reduce electrical loads. Selecting the galley push-button switch to off will disconnect all power from the main and secondary galleys. The galley push-button switch will indicate fault with an ECAM caution generator overload when the APU generator or an engine-driven generator's load is greater than 100%. The ECAM displays galley shed in white when the galley push-button switch is selected off, or if the main galleys are automatically shed due to the electrical system being powered by only one engine generator. Transformer rectifiers, or TRs, convert 115-volt AC power to 28-volt DC power. The electrical system has two main TRs, TR1 and TR2, which supply up to 200 amperes of DC current. TR1 is powered by AC Bus 1, and TR2 is powered by AC Bus 2. A third TR, the essential TR, will power the essential DC circuit from the emergency generator if all the main AC generators fail, or if TR1 or TR2 fails. The label TR1 or TR2 is displayed in white, changing to amber if voltage or current limits are exceeded. TR voltage and current are normally displayed in green, becoming amber when normal operating limits are exceeded. The essential TR has the same ECAM indication as the main TRs. The voltage and current are not displayed when the essential TR contactor is open. There are two DC batteries, each permanently connected to its respective hot bus. Each battery has a battery charge limiter, or BCL, which controls battery charging and the battery contactor. The electrical panel displays the battery voltage for battery 1 and battery 2 in white, even if the aircraft is not powered by an electrical source. Battery 1 and 2 push-button switches control the operation of the battery charge limiters. In their normal auto lights-out position, the BCLs automatically control the connection of the DC batteries to the DC battery bus by opening and closing the battery line contactors. The batteries are connected to the DC battery bus for APU starting, or if battery voltage is below 26.5 volts, so the battery can charge. The batteries are also automatically connected to the DC battery bus with a loss of all normal and emergency power below 100 knots. Touch the battery 1 push-button switch to turn it off. When a battery push-button switch is selected off, the respective battery line contactor will open, and off illuminates in white if the DC battery bus is supplied. However, the hot buses always remain powered. The battery push-button switch will indicate fault in amber with an ECAM caution when the charging limit of the battery is outside the set limits. When the fault is triggered, the battery line contactor opens to disconnect the battery from the DC battery bus, thus preventing any further charging. The labels BAT1 and BAT2 are displayed in white, changing to amber if the associated voltage or current are outside limits. Battery voltage and current are normally displayed in green, becoming amber when normal operating limits are exceeded. With the battery push-button switch selected off, off is displayed in white, replacing the voltage and current readings. The ECAM displays the various connections of the batteries to the battery bus by lines or arrows, indicating the charging status of the batteries. The green arrow to the battery indicates the battery contactor is closed and the battery is being charged with a current greater than 1 ampere. The amber arrow away from the battery indicates the battery is supplying power and the current is greater than 1 ampere. The arrow changes to a green line if the current is less than 1 ampere, and there is no line displayed if the battery contactor is open.
The static inverter converts DC power from battery 1 to single-phase 115-volt AC power, which will supply part of the AC essential bus. If the aircraft is above 50 knots, the inverter is automatically activated if nothing but the batteries are supplying electrical power, regardless of the position of the battery 1 and 2 push-button switches. If the aircraft is below 50 knots, both the battery 1 and 2 push-button switches must be in auto.
Voltage and frequency of the static inverter are normally displayed in green, becoming amber when normal operating limits are exceeded. In the normal operating configuration, TR1 supplies DC bus 1, which supplies the DC battery bus through the DC tie contactor. TR2 supplies DC bus 2. In the event of a fault on the number 1 DC system, the DC battery bus can be supplied by DC bus 2. The ECAM indications for DC bus 1 and DC bus 2 are normally green, changing to amber when the corresponding bus is not powered. The ECAM displays the line contactors as green lines between the various DC buses and the TRs. Normally, the DC battery bus supplies the DC essential bus through the essential DC tie contactor. When required, the DC battery bus will also charge the DC batteries through the battery contactor. The ECAM displays the DC battery bus normally in green, changing to amber if the voltage is 25 volts or less. Normally, the DC essential bus is supplied by the DC battery bus, but may also be supplied by the essential TR or directly by battery 2 in abnormal configurations. The ECAM displays the DC essential bus normally in green, changing to amber when the DC essential bus is not powered. Normally, the DC essential shed bus is supplied by the DC essential bus and will be automatically shed when the DC essential bus is being supplied by battery 2 only. This will be the case if the emergency generator is supplying the electrical system and the landing gear is extended. The ECAM will display shed in amber when the DC essential shed bus is off. The 2 DC batteries are permanently connected to their respective hot buses. A ground power connector, located forward of the nose wheel, allows external power to supply the entire aircraft electrical system. A ground power control unit, or GPCU, protects the electrical system by controlling the external power line contactor. The interphone panel, located next to the ground power connector, has 2 lights, allowing ground personnel to monitor the status of the external power. The available light will illuminate if external power is within limits, and the not in use light indicates external power is not being used and can be removed. The external power momentary action push-button switch is located on the electrical panel. The push-button switch will not have any lights illuminated if external power is not connected. It will display a veil in green if external power is connected and within limits, and on in blue if external power is selected on and powering the electrical system. With the external power push-button switch indicating a veil, pressing it momentarily closes the external power line contactor, allowing external power to supply the electrical system. The veil light goes out, and the blue on light illuminates. Touch the external power push-button switch to connect external power. With the external power push-button switch indicating on, momentarily pressing it opens the external power line contactor, the on light goes out, and the veil light illuminates. Touch the external power push-button switch. The ECAM electrical page does not display any external power indications when external power is not connected to the aircraft. When external power is available, the label External Power is normally displayed in white, changing to amber if voltage or frequency exceed limits. Voltage and frequency are normally displayed in green, changing to amber when normal operating limits are exceeded. When external power is selected on, the ECAM electrical page displays the external power line contactor as a green line. The maintenance bus switch is used to power only the electrical systems used for ground servicing, without powering the entire aircraft electrical system. The maintenance bus switch is located in the forward galley ceiling just inside the forward entry door. On the ground, only the equipment required for servicing the aircraft can be supplied directly through the maintenance bus switch without powering the entire aircraft. With the external power switch indicating a veil, the maintenance bus switch, when selected on, will be magnetically held in the on position until ground power is removed. In the on position, only the AC and DC ground flight buses have power, which will supply the cabin, cargo hold, and landing gear compartment lighting, the cockpit flood lighting, the vacuum cleaner sockets, the yellow electric pump for cargo door operation, the refueling panel and fuel quantity indications, the ground call system, and the navigation lights. With the maintenance bus switch selected off and the external power selected on, the entire aircraft electrical system is powered by external power, and the AC and DC ground flight buses are powered by AC Bus 2 and DC Bus 2 respectively.
If both AC Bus 1 and AC Bus 2 lose power, the ram air turbine, or RAT, automatically extends to power an emergency generator at a constant speed through the blue hydraulic system. The emergency generator is controlled by a generator control unit to produce 5 kVA of three-phase 115, 200 volt, 400 Hz power. The emergency generator will supply power as long as the landing gear is retracted and the aircraft speed is greater than 100 knots.
The two batteries are capable of temporarily powering some of the emergency generation network through a static inverter when no other electrical power source is available, such as during RAT extension, which lasts about 8 seconds, or after the landing gear is extended when the emergency generator was powering the system. The emergency electrical power panel is located on the overhead panel to the left of the electrical panel. It contains controls and indicators for the RAT and emergency generator. Caution: do not confuse the RAT and emergency generator manual on push button with the hydraulic RAT manual on push button located on the hydraulic panel, and vice versa.
The manual on push button switch is normally in its guarded auto position, which allows automatic RAT extension in case of both AC Bus 1 and 2 not being powered and the aircraft speed above 100 knots. The RAT powers the blue hydraulic system, which drives the emergency generator. When the emergency generator parameters are within limits, it is automatically connected to the electrical system. Lifting the guard and pressing the manual on push button switch extends the RAT at any time and connects the emergency generator after a 3-second delay. The RAT and emergency generator light will indicate fault in red if the emergency generator is not supplying power when AC Bus 1 and AC Bus 2 are not powered and the nose landing gear is retracted.
The guarded emergency generator test push button is used for maintenance purposes only to test the emergency electrical system. The Gen 1 line push button switch will indicate smoke in amber with an ECAM warning if smoke is detected in the avionics compartment.
In the avionics smoke procedure, the Gen 1 line push button switch is selected off, which opens the Generator 1 line contactor. Generator 1 continues to run and supplies one fuel pump in each wing tank. The procedure then calls for extension of the RAT to connect the emergency generator. Once the emergency generator is available, the APU generator and Generator 2 are selected off, which sheds about 75% of all electrical equipment, in an attempt to isolate the smoke source.
The ECAM electrical page displays the label Emergency Generator in white, changing to amber if the voltage or frequency are out of limits. The voltage and frequency of the emergency generator are normally displayed in green, becoming amber when normal operating limits are exceeded. Voltage and frequency indications are not displayed when the line contactor for the emergency generator is open. When the RAT is extended, RAT out appears in green in the memo section of the upper ECAM display. If the emergency generator is running, EmerGen will also be displayed.
The electrical portion of the configuration safety check is performed by the first officer, only if electrical power has not been on the aircraft for more than 6 hours. This test will ascertain if electrical power can be applied safely, or if battery charging is required. First, with the battery push-button switches off, check the battery voltage on the overhead electrical panel. If the battery volts are above 25, then select battery 1 and 2 push-button switches to auto. Note, if the APU is to be started on batteries alone, the APU should be started within 30 minutes. If the battery volts are 25 or less, select the battery push-button switches to auto and establish external power for 20 minutes to charge the batteries. On the ECAM electrical page, verify the batteries are charging and repeat the test after 20 minutes to confirm proper battery charge.
During the cockpit geographic check of the emergency electrical panel, check that the emergency generator test switch is guarded and that the generator 1 line push-button switch is set to the in lights out position. Check that the RAT and emergency generator fault light is out and that the manual on push button is in its auto-guarded position. During the cockpit geographic check of the electrical panel, the first officer will pre-select the electrical page on the ECAM by pressing the electrical push button on the ECAM control panel. Touch the electrical push button on the ECAM control panel to display the electrical page. The captain will select battery 1 and 2 push button switches off, pausing until the batteries indicate off on the ECAM electrical page. Touch the battery 1 and 2 push-button switches to turn them off. The battery 1 and 2 push-button switches will then be selected back to the on position while checking on the ECAM electrical page that both of the battery charge currents decrease below 60 amps within 10 seconds. Touch the battery 1 and 2 push-button switches to select them back to on while checking the battery amps. After the battery test, check that the generator 1 and 2 fault lights are illuminated, as the generators are not running at this time. Then, check that all other push-button switch lights are out. The external power switch may indicate avail or on, depending on whether external power is connected or selected on. The APU should be started a minimum of 10 minutes before departure. With the APU running and the APU start push-button switch indicating available, the electrical power can be transferred to the APU generator by pressing the external power push-button switch, which will disconnect external power and automatically switch to the APU generator. Once power is transferred to the APU generator, the external power can safely be removed. Touch the external power push-button switch to transfer power to the APU generator.
When the engines are started and the engine generator output is normal, the associated generator line contactor will automatically close and connect the generator to the electrical system, as they have priority over the APU generator. When both engine generators are supplying the electrical system, the APU master switch may be selected off, at which time the available light will extinguish. If the APU was using APU bleed air, the APU will keep running at 75% power for a cooling period of 60 to 120 seconds. Touch the APU master switch to shut down the APU.
After arrival at the gate, if the APU is running and available, the APU generator will automatically supply the electrical system as the engines are shut down. If external power only is available or desired, one engine may be shut down until external power is connected. Once the external power avail light illuminates, external power can be selected on. It will automatically supply the aircraft as the second engine is shut down. A fault in one of the engine generators will trigger the generator fault warning. A single chime will sound, the master caution light will illuminate, the fault light on the generator push-button switch will illuminate, the ECAM electrical page will automatically be displayed, and the ECAM memo area will display the required actions. As can be seen for the generator 1 fault, the number 2 generator is automatically supplying both electrical systems through the bus tie contactors. The main galley is also automatically shed due to one generator operation. The ECAM actions are to select the generator off, then on, to try and reset the generator. If the generator does not reset, select the generator off. Assuming the generator did not reset, touch the generator 1 push-button switch to turn it off. With the generator 1 push-button switch selected off, the ECAM electrical page will display generator 1 off, with generator 2 supplying both AC bus 1 and AC bus 2. The APU, if available, may be started, and when the APU generator is within limits, it would automatically supply AC bus 1 and recover the main galley. Touch the right arrow to display the ECAM electrical page with the APU generator connected. With the APU generator operating normally, it will automatically connect to AC bus 1 through the bus tie contactor, replacing generator 1. Now with 2 generators online, the main galley will not be shed.
If IDG oil pressure is low or overheats, the IDG oil low pressure or overheat fault will be displayed. In this case, the IDG1 low oil pressure fault is triggered due to low oil pressure in the IDG. The ECAM action is to disconnect the number 1 IDG drive from the engine. The guarded IDG push-button switch is held in until the generator push-button switch indicates fault. Do not push the IDG push-button switch longer than 3 seconds, or damage to the disconnect solenoid may occur. Touch the IDG1 push-button switch to complete the ECAM actions.
When the IDG is disconnected, the fault light on the generator 1 push-button switch will illuminate. The ECAM electrical page will display 0 voltage and frequency for generator 1, and the main galley is automatically shed due to one generator operation. The IDG indication will display disconnect in amber, confirming the IDG has been disconnected. The battery fault is displayed if a battery has excessive charging current. The associated battery contactor automatically opens, disconnecting the battery from the DC battery bus. This is a crew awareness fault with no ECAM actions required. If a generator load is above 100%, a generator overload fault will be triggered. The Generator 1 overload fault displays Generator 1 at 120% load. The ECAM action is to select the galley push-button switch to off, reducing the generator load. Touch the galley push-button switch to turn it off. The AC bus fault is the result of an AC bus losing power due to a fault on the bus. With an AC bus 2 fault, the lower ECAM display is lost as it has no power supply. The only ECAM action is to select the extract fan push-button switch to override, putting the avionics ventilation system in the closed-circuit configuration, adding air-conditioned air to the ventilation system. The status page will display a long list of in-op systems. Refer to FCOM 3.02.24, Abnormal and Emergency Procedures. To display the ECAM electrical page, the electric push button on the ECAM control panel must be held continuously, which will display the electrical page on the upper ECAM. Touch the electric push button on the ECAM control panel to display the electrical page on the upper ECAM. As can be seen on the ECAM electrical page, the DC Essential bus, normally supplied by DC Bus 1, is now automatically supplied by the Essential TR. DC Bus 2, normally supplied by TR2, is automatically supplied by DC Bus 1 through the DC battery bus. A failure of the normal power supply to the AC Essential bus will cause the AC Essential fault to be triggered. The upper ECAM display is lost due to no power supply, which causes its display to be automatically transferred to the lower ECAM. The first ECAM action is to select the AC Essential Feed push-button switch to alternate to try and restore power from AC Bus 2. Touch the AC Essential Feed push-button switch to transfer electrical supply to AC Bus 2. If the transfer of power to AC Bus 2 is successful, the equipment powered by the AC Essential bus will return to normal. If the electric push button on the ECAM control panel is selected, the electrical page will be displayed on the lower ECAM. Notice that the AC Essential bus is now supplied by AC Bus 2 through the AC Essential Feed contactor. With the DC Bus 1 fault, the DC Essential bus, normally supplied by DC Bus 1, is now automatically supplied by the Essential TR. The DC battery bus, normally supplied by DC Bus 1, is now automatically supplied by DC Bus 2. There are no ECAM actions directly related to the electrical system, as all switching is automatic. The status page lists all the in-op systems. Refer to FCOM 3.02.24, Abnormal and Emergency Procedures. If one of the green monitored circuit breakers should trip for more than 1 minute, the CB tripped advisory will be displayed. The ECAM warning will include the name of the panel on which the CB is located. There is no requirement to reset a tripped CB, but one reset may be attempted. If the reset is unsuccessful, a second reset must not be attempted.
With the loss of AC Bus 1 and AC Bus 2, the ram air turbine will automatically extend, putting the aircraft in the electrical emergency configuration. Due to the complexity of this fault, only the initial warnings and electrical page configuration will be covered at this time. Complete coverage will be provided in simulator lessons. The initial warnings for the electrical emergency configuration fault are a continuous repetitive chime, the master warning light, the ECAM warning, and a momentary fault light on the RAT and emergency generator push-button switch as the emergency generator comes up to speed. The lower ECAM display is lost due to no power supply. When required, the electrical page can be displayed on the upper ECAM display, by pressing and holding the electrical push button on the ECAM control panel. Touch the electric push button to display the electrical page.
The RAT has automatically deployed, driving the emergency generator, which supplies the AC essential bus and the DC essential bus through the essential transformer rectifier. In this configuration, numerous systems are lost, which are listed in FCOM 3.02.24, Abnormal and Emergency Procedures. If smoke is detected in the avionics ventilation system, the avionics smoke fault is triggered. Due to the complexity of this fault, only the electrical portion will be covered. Complete coverage will be provided in simulator lessons. The ECAM actions for the electrical portion are performed 5 minutes after the avionics ventilation system is put into the smoke configuration. If there is still smoke after 5 minutes, the emergency electrical generator line 1 push-button switch is selected off, which opens the generator 1 line contactor and automatically connects generator 1 to 1 fuel pump in each wing tank. Touch the generator line 1 push-button switch to turn it off. Next, the emergency electrical power manual on push button is pressed, which will extend the RAT to power the emergency generator. Touch the manual on push button switch to extend the RAT. When the emergency generator is available, the APU generator and engine generator 2 are selected off, putting the electrical system into the emergency configuration, which sheds about 75% of all electrical equipment in an attempt to isolate the smoke source. Touch the APU generator and engine generator 2 push-button switches to turn them off. In-op systems are listed in FCOM 3.02.24, Abnormal and Emergency Procedures. As the lower ECAM display has lost power, when required to display the electrical page, the electrical push-button switch on the ECAM control panel is pressed and held, which will display the electrical page on the upper ECAM display. Touch the electrical push button on the ECAM control panel to display the electrical page as if all ECAM actions are complete. The electrical page displays the DC essential and AC essential buses supplied by the emergency generator. Generator 1 is not connected to AC bus 1, but is running and powering 1 fuel pump in each wing tank. Before landing gear extension, the procedure calls for the generator 2 and emergency electrical generator 1 line push-button switches to be selected on in order to restore normal electrical power supply for landing.